This is the greatest and best class in the world. Pre-AP Geometry. A tribute. All right, party people, how we doing? We're going to start off with our first video of Pre-AP Geometry with a little thing, and you might get excited here. I know some of the guys are like, "Oh, Jonas Brothers, I love the Jonas Brothers." I don't know their names because I don't really listen to the Jonas Brothers, but I'm sure a lot of you guys and girls out there are thinking, "Oh, I love the Jonas Brothers. They're my favorite. Why did that one have to go off and get married? I'm so sad." But here's the main thing. What do all of these movies have in common? And if you notice, the big thing that they all have in common is that they are all in 3D. But really, what does it mean to watch a movie in 3D? What D do we normally watch movies in? And that's what we're going to be talking about are the D's of geometry. So typically we watch movies in 2D, or at least the way I watch movies. I don't know if you guys pay the extra money to watch them in 3D. I get a little sick. I wear glasses. It's tough for me to wear two pairs of glasses. Now I'm what, like 8 eyes or something instead of 4 eyes. And, it just compounds there. But we're going to talk about the D's of geometry in this first video. So our first D is a point. Okay, point is basically it's really no dimensions. Okay, it's a specific place in space. So this is what you need to write in your notes for your very beginning part there. I have point, and you just need to write these definitions here. It is a specific place in space. It has no dimension, zero dimensional. It has no length, width, or height. Okay, basically when you draw in a point, like I just put there, which is very teeny tiny, you could sit there and pretend like, oh, well, I could take a ruler and I could measure that, and it's going to be like 1 millimeter. But technically, a point doesn't really have width or length to it. Okay, you you have to see it in order to believe it, but it really doesn't have any value to it whatsoever. It is just a specific place in space. That's why we are calling this essentially an undefined term of geometry. We will later have defined terms. Okay. So what does a point look like? Well, surprise, surprise, it looks like, amazingly, a point. And there will be a capital letter next to that point. Now, I just started with the beginning of the alphabet and put A right next to it. Do I have to put A and start at the beginning of the alphabet? Absolutely not. You can put whatever letter you like there. But typically it is a capital letter, okay? And it's just a regular block letter. It's nothing cursive-y, nothing fancy. We will talk about cursive-y, fancy capital letters in a bit here. How do I write it mathematically? Well, easy as it gets. You just specifically say point, and then whatever letter you used up here is used to describe that point. Okay? So there is no shortcut way to represent a point. You just have to use the actual word point. Next up, a line. Line is now, we're bumping up a dimension, one dimensional. It has length, which is infinite. So technically a line goes on and on forever. And when we talk about lines, we are talking about lines being straight and never curved. Okay, so lines go in opposite directions, infinitely long. There is no end to lines. What's it look like? Well, kind of looks like this. You have points on a line, and really a line is made up of infinitely many points. Okay, technically I could put in as many points as I wanted to. I'd have to name each one of these points something, but technically this whole line is made up of infinitely many points, and if you kind of think about connecting all of those points together, essentially you have your line. Okay, so a row, if you will, of infinitely many points creates a line. And you will notice that there are some points on our line, but we also have this thing down here which really doesn't have a point, and it's cursive. It is lowercase cursive. I know some of you guys may not have really dealt with cursive back in elementary school. I know it's not really the cool thing to do these days in school, so we'll do a little bit of cursive stuff, but not a lot. How do I write it mathematically? Well, there's a couple different ways, okay? There's, maybe an easier way, maybe a little bit tougher way. I think they're both equally the same. If you have this cursive letter, this lowercase cursive letter, which it will not always be there, but if it is there, then you can use the word line with that lowercase cursive letter. Okay? So we can say that's line L, if you will. Or you can use points on the line, and it takes 2 points to create a line. Can't just get away with one because technically there are infinitely many lines through one given point. So we could call this line AB, and we notice now we're not using the actual word line. Now we've got a little shortcut symbol, if you will, which is right above here. It looks like a little miniature line. Okay, so you write the 2 points that are on that line, so AB, and notice I can flip it around backwards and say BA. It doesn't really matter which way you name your 2 letters there, as long as they're both on that line that you want to name. And then we put a little baby line, if you will, up above the 2 letters. It is very important, that you put the arrow caps on both ends of those. Because if you only put one arrow cap, that means something else. If you don't put any arrow caps, it means something else. So technically 2 ways to write mathematically a line. You can use the lowercase cursive letter if it exists. Otherwise, you're going to use 2 and only 2 points on that line. And it doesn't matter if you name it forwards or backwards. You just need to make sure you put the little baby line right on top of it. Our third undefined term of geometry, now we're bumping up again from 1 dimension to 2 dimensions, is a plane. Think of a plane as basically the largest sheet of paper you have ever seen, that you just keep looking around in every direction and there's paper. Okay, there is no end to this paper. So it is a flat surface that extends infinitely in all directions. It has 2 dimensions, length and width, and it is made up of infinitely many points and lines. So imagine on this piece of paper, you could go to town till the rest of your life putting points on this piece of paper, drawing lines on this piece of paper. Since the paper goes on infinitely and lines go on infinitely, if you started to draw a line, you could keep drawing this line till the day you die and you still wouldn't be done because it keeps going on and on and on. It's kind of like infinity itself. So what does it look like in your book? Well, we can't really draw something that's infinitely big, right? So we typically will see something that kind of looks like a parallelogram, if you will, a tilted over rectangle. And in that plane, again, there's going to be a couple different ways that you could name it, and we'll get to how to write it. But you will mostly see points, you might see some lines in here, and then you might see a capital cursive-y fancy looking letter in a corner. Typically it's in a corner. Okay, it's not usually going to be like randomly in the middle of the plane, but stuck somewhere in the corner. Does it have to be there? No. But if it is, it makes things a lot nicer. So now how to write it. And again, a couple different ways like the line. If there is that cursive letter stuck in the corner, then you can use the word plane with that capital cursive-y looking letter. Okay? Or if that capital cursive-y looking letter is not there, then it takes, here's the thing, at least 3. 3 or more. Now, my rule of thumb is just use 3. If you can get by with 3, why do more? Okay? Now, I've got a term here that we haven't quite defined, but we will later, called non-collinear points. Non-collinear, if you break it down, we have non, which we would think it means not, and co kind of means together, and then linear. So not with the same line points. So at least 3 points that don't make a line is basically what it's saying. So I've got here as an example plane ABC. Notice A and B together, they're on the same line. They would be called collinear. But when you include C into the mix, now all of a sudden these 3 points are non-collinear. They don't make up a straight line. So these 3 non-collinear points uniquely create this one plane, and no other plane could you confuse it with. All right, I could have also named it plane CDE. I could have named it plane BDE. As long as I pick any 3 points that don't make a straight line, I'm fine. Now the thing is, you can't use the capital cursive letter because it's not really a point. Okay, so I couldn't name it plane ABP. A and B are points, but P isn't really a point. Okay, it's like a permanent tattoo that's there on the plane's shoulder. It's not really a point, so you can't use it. You either use it by itself or not at all. So first example, let's name this line 3 different ways. Now the first thing I would look for is, do I have that lowercase cursive letter? And in this case, I do. So I'm going to start out by saying we could call this line B. Now, notice it's not really a cursive B. Technically this would be our cursive B for those that are cursive literate, but it doesn't have to be. As long as you've got lowercase, because all of our points are going to be capital, then that's how we're not going to get confused with that. So there's one way of naming this line. A second way of naming this line, if you think about it, I said you only need 2 and only 2 points on a line to name it. So we could call this line, maybe I just pick those two and say MU. And then I got to remember to put the little baby line up on top of it. Okay? I could say UW, I could say WX, but here's one thing that always seems like the last possibility that people kind of, yeah, I was afraid that's going to happen, kind of leave out. And that is, you can skip over letters if you like. So for example, I could call this line MX, put the little baby line on top. I can just skip over U and W, it doesn't really matter. These 2 points, M and X, they're on this line, so I can just use them to name it, okay? Or I can flip these around backwards and say line XM or line UM, but notice B, again, is not a point. So I can't say line MB like this. That would be an incorrect way of naming it. Second example, name this plane 3 different ways. All right, so number 1, I'm going to be looking for that capital cursive-y looking letter, which I do happen to have here. I've got this curly Q, Q. So I could call this plain fancy Q. There we go. Looks like it has a little mustache there. Now, besides that, we said it takes at least 3 points to name a plane, but those 3 points had to be non-collinear. Well, luckily for me, there really aren't any points that are 3 points anyway that are collinear. I can't connect 3 dots and go, oh, look, those 3, that makes a straight line right there. Doesn't work. So otherwise, I can just pick any 3 points I want. As long as I don't pick that Q there, I'm good. There's also another letter here that I technically can't pick, and that would be this guy. I mean, technically there's supposed to be a little curl on that. I mean, that's to name this line, F. So technically I can't use that because that's specifically for the line. So I could say plain GJL. So there's GJL, and that uniquely defines this plane right here. I could say plain AZN. There's AZN, and there's 3 non-collinear points. If I wanted to pick just points and nothing on lines, I could say plain GRN, and that would work. You could get wild and crazy and say, all right, I'm gonna go all out here. Let's go plain GJLRZAN, Grajadzelzen. That's a big plane. All I said was it took at least 3 points to make a plane. And this happens to be at least 3. It happens to be, what, 7 points. But all 7 of these points are on that plane. So if you really wanted to, you could call it Grajadzelzen. But I would just go with one of these other examples that only use 3. Okay, but keep in mind it's 3 or more. Next up, some vocab. Postulate or axiom. We are going to focus more on the term postulate, especially when we get more into second semester. We're going to do some proofs of proving that certain geometrical things are true. And we have to use these things called postulates. And postulates, or axioms, if you will, are just an accepted truth. It's something so basic that you can't basically disprove it. Okay? It's like saying, why is the color red red? Well, the color red is red because it was just defined that way to be called red. You can't question why it's called red. That's just the way that it was. So there's no need to prove that a postulate or an axiom is true. So again, later we will look at postulates. And there are things called theorems which must be proven true. And we will have to prove those later on in this course. So the first postulate in the book basically deals with this. How many points does it take to make only one unique line? Okay, so I've got 1 point here, point H. And is there only one unique line that can use point H? And the quick answer would be no. Okay, for example, I could have this line that goes through point H, but I could also have a separate line. All right, I gotta remember where I was because I just had some teachers come in and talk to me. Anyway, here's one line through point H. But notice I could have a second line that's different than that line that also goes through point H. And I could have a third line and a fourth line and a fifth line and a sixth line. Notice I could technically create a very cool pattern here if you're noticing here. If I went on forever and ever, I can make infinitely many lines that go through this one point. So one point does not make one unique line. So this is where I need the assistance of South America. And you might be thinking, South America, what are you talking about? Well, I could take point P from South America down here and say, all right, now if I wanted to make a line that goes through both H and P, is there any other line that I could create that would go through H and P that's not this line? And the quick and easy answer would be no, you couldn't. And you couldn't say, well, what if I had a line that did this? There, I made a line, goes through H and P. But we define lines to be straight and not curved. So for postulate 1-1, how many points does it make to make only one unique line? It takes 2 points to make a line. The second postulate in your book says if two lines intersect, then their intersection is a what? So here, notice here, here's two lines, and here's where they cross. And notice I already have an R right here, but what do you think that R really represents? Well, it represents a point. Now notice there was no point really there, okay? You can put a point there, but you'll notice the book will not put points where two lines cross. It's basically understood, aka it's a postulate, it's a given, accepted truth there, that that will be always a point. So you don't have to draw a point, but you should see usually some sort of letter to indicate, hey, there's really a point here. It's not seen as a point, but it is definitely a point. So the intersection of two lines, or really more than two lines, it could be even, is a point. All right, so let's name the intersection of lines PS and QR. So here's line PS, here's line QR. Where do they come together? They come together at, now here's the thing, they don't come together at R. What are you, a pirate? You're saying R. No, they meet at point R. You have to be specific. This is how you name a point. You have to use the word point, so don't leave it out. The intersection of TV and QU. All right, here's TV. Whoop, getting crazy here. Here's TV. Here's technically QU. Where do they come together? At not U, but point U. Now let's try one if we didn't even have a picture. Where would line WR and line RB intersect? Well, if we don't have a picture, how are we going to know where they come together at? This seems a little weird. But even if you just drew a picture here to kind of think about it, let's say here's WR. So let's get some points here. Let's call this W and let's call this R. And then we have another line RB. Well, if we draw in a second line that's different, and we know that it's got to go through R, maybe it looks something like this, and maybe here's where B is. Well, those two things come together at R. So one nice thing here is a way that you can easily get the answer is, well, what do these two lines have in common? Well, they both have the R in common, which means they must intersect together at, oh, not yellow, let's try this, at point R. All right, almost done here. We're going to do something backwards now. I'm going to give you the point of intersection, and you got to tell me the two lines that cross at that specific point. So first off, point H. Well, here's point H, and notice there is no technical point there because it is the intersection of two lines. Well, point H comes from this line right here, and what other line crosses through it would be that line right there. So we could say this line right here, we could call HZ. Put my little baby line above it. Or you could call it ZH, it doesn't matter, forwards or backwards. So that line and this line, we've got three letters to pick from. L, X, and H. Do we have to use the H? We technically don't have to, okay? So I could say line LX and HZ intersect. Now, if this was a blind problem, if we didn't see that picture there, and I said, hey, does point H, is that the point of intersection with lines HZ and LX? You go, I don't really know. There is no letter that's in common here. So this is an example of where you really do need to see the picture. Now for the second one. Racing too much there. Let's do this. I'm going to have you guys come up with an example of where two lines meet at point L. So I'm going to ask you guys tomorrow the answer to this. And we're going to have a variety of answers. There's not just one unique answer. So go ahead and you can just pause the video if you like, do that problem real quick, and we will discuss it tomorrow in class. And that is the end of the first video. I hope you guys were able to keep up with me. If there's anything at any point in the video that was confusing to you, please make a note somewhere in your notes. That way the next day in class, you can flip through them and go, Mr. G, I didn't really understand whenever you did this example or when you talked about this vocabulary term. Can you clarify it for me? Can you help make me understand it better? Okay? Or if you come up with an example that you're like, well, here's my example. Does it work the same way as this example worked out? We can definitely discuss that and use that as an in-class opportunity. All right, so adios and goodbye.